We are now going to have a very special lesson on a topic that I know is going to be very, very important for you growing up, especially in this beautiful subject called mathematics. Okay? So we're going to be introducing a topic called algebra. Okay? We're going to discuss many things, and many examples, but I'm also going to share with you the learning outcomes as we normally do. You can remind me again, what is a learning outcome? Learning outcome. What do we need to know? Okay, everybody, learning outcome is?
What you need to know.
Okay. What is success criteria at the moment?
What you know.
It's a good try. It's a good try. Oh, yeah? It's a good try.
How you know. No. What you need to know.
You're on the right track. Well done. You're definitely on the right track. Appreciate it.
How you know that you know. Wait, how you know that you know what you need to know.
Exactly. Okay, together, how you
know
that you
know
what you
need to know.
Fantastic. Okay, so we're going to begin the lesson from the very beginning and ask you a couple of very important guiding questions that can help you and assist you to understand this concept that we're teaching. Okay, what can you tell me? What can you see? Rahim, what can you see?
I see a man.
You see a man? Okay, good. So your eyes immediately went to the man. Any idea who the man is? No clue. Do you think you know? Oh, clever man. Maybe. We'll see as the lesson progresses. Okay. What else do you see that's familiar to you on the screen? Hello. You see alphabet. Okay. Anything specific about the alphabet? Yes. Do you know any of these characters?
Yes.
Okay. What's this character?
Any apple.
Any apple. Ah, do you remember learning about any apple?
Yes.
Okay, so when we introduced you to letters of the alphabet, we gave them names. Okay, who remembers this guy? Bouncing bear. Wow, do you still remember Bouncing bear?
Yes.
Okay, we'll go, what about this one here?
Cat.
Clever cat. I hope today we are all going to be like clever cats and make sure that we answer our questions as best we know, and we can proceed to go into this lesson and enjoy. Okay, so this is an introductory course to algebra. Alright, now as I said, we want to talk about the learning outcomes. Okay, so I'm going to ask the person to explain to us what they understand about that learning outcome. Let's read it together, then I'm going to ask one of you to explain what you understand from that learning outcome. Okay, the first learning outcome, let's go. Learners will be able to define the term algebra and how it is used in mathematics. Who thinks they can explain what that means? Fatima.
It means that we should be able to define, to know what the term algebra means and how it is used in math.
Excellent. So we'll be able to know exactly what algebra is. Very, very good answer, Fatima. Well done. Let's look at the second learning outcome. Okay, let's read it together. Learners will be able to carry out basic mathematical operations involving algebraic expressions. Oh, that's a bit more complicated. What on earth does that mean? What are we going to be able to do after we've learned about algebra? Anybody want to try to do that?
We can do calculations on algebra.
Good. I like the word calculations. Okay, we'll be able to carry out basic calculations. Remember in mathematics, when we talk about the word operations, we're talking about things like what? Addition, yes. What else? Subtraction, very good. What else? Addition, multiplication. Okay, so we'll be able to carry out those basic operations involving, what do you think algebraic expressions are? Do you think that's a technical term? What do you think algebraic expressions are? What could they be? Do you think that by the end of this we'll be able to explain what an algebraic expression is?
Yes.
How many of you think that we're going to be able to know what an algebraic expression is? Very good. Well, let's see what happens. Okay? Let's see what happens. The third learning outcome, let's read it together. Learners will be able to create and solve simple equations. What do you think that means? Anybody? What do you think that means? Rahim?
Will be able to solve different easy equations.
Easy equations. So you've equated the word simple to easy. Very good. What do you think the word solve means? What do we mean when we say we'll be able to solve create and solve. Which is
Calculate the.
able to calculate, work it out systematically, step by step, yeah? Yes?
Yes, sir.
Okay, let's see what we're going to learn about today. Alright? Alright, now, before we get into the workbook that I've put on your tables, we're going to use the whiteboards like this, and I want you to number your whiteboard 1, 2, 3, and 4 like that. From the top, 1, 2, 3, and 4. So space it out nicely like that. 1, 2, 3, and 4. Okay, 1, 2, 3, and 4. It must be visible and you must be able to see. Come on, just right. 1, 2, 3, and 4. Okay? With this leaking, let me just replace the 2 pins that you've got there. What else? Okay? That's fine. We'll replace this one. Use that one. Use that one. Oh, yeah? Those also need to be replaced. Okay. So what you're going to do there, don't worry about it. Okay. Okay. So 1, 2, 3, 4. Okay. Now, for the first one, this is the one that you're going to enter under number 1. Okay. There's a question on the board. Somebody read the question for me?
Look at the picture.
Okay, look at the picture on the. Here's the question. Is this a letter or a number? Now, what I want you to write on your whiteboard is whether what you see right now is a letter or a number. Okay. Is a letter or a number. Don't put up your boards yet. Just write your answers. Whether it's a letter or a number. Okay, just write down. What do you think? That a letter or number. Ignore the eyes, and the hands, and the expression. We're looking at the central figure in the middle of the board. Is that a letter or a number? Okay, now hold up your boards. Let's see what your answers look like. Aha. Alright, so we all recognize. Very good, very good, very good. It's a number. Okay, very good. Let's look at the next one. Okay, same thing for number 2. Look at the picture below. Is that a letter or a number? Is it a letter or a number? Just out of interest, who recognizes this particular character, please? What's her name? You forgot her name. Who remembers? Angela. Golden Girl. So Golden Girl is a what? Is that, hold up your boards and see? Is a letter. Okay, so the first one was a number, the second one is a letter. Fantastic. Okay, let's continue. Look at the picture below. Okay, question to follow. Is it a letter or a number? Number 3. Is it a letter or a number? As soon as you're ready, you can hold up the board. Good, 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 good. Continue, let's see. Very nice. Excellent. Oh, fantastic. So we recognize that is a number. And the last one, okay, who remembers this guy? Okay, what's his name? Munching Mike. Wow. Okay, same drill. Is it a letter or a number? Identify. Is that a letter or a number? Is that a letter or a number? And then hold up what you've got there. Alright, so the first one's a number, the second one's a letter, third one's a number, the fourth one is a letter. You can put a little tick on your boards, give yourself a mark on the floor. Well done. Great job, everybody. You all know the difference between letters and numbers. Now, that's going to be really important as we proceed with our lesson. Okay? So we can differentiate between letters and numbers. Now, I've given you all an algebra workbook. Okay? You can put your boards to the side, put your algebra notebook in the middle of the desk. Okay? Leave the boards there. I'm going to give you for now. Right, so we all have an algebra workbook that I've got in front of you right now. And I've already asked you to write your names and instructions. So this is the workbook is what we're going to use to carry out all our tasks as we do the different worksheets. Okay, so total of 4 worksheets and we're going to work through these systematically. Okay, your see your learning outcomes are written there at the top. Alright? So I want you to pay attention to what I have on the screen. Okay? So for now, don't worry too much about what's in the workbook. I just wanted you to be aware that we are going to be learning some specific things, and we're going to be working in our collaboration groups and your think, pair, share groups. Remember to keep the noise level controlled, to maintain social distancing, and to keep your masks on throughout the lesson. Right, now look at the group of letters and numbers on the board. If you want to look at the board, for instance, look at the board. Okay, look at the board. Look at the board. Okay? Look at this group of letters and numbers. Okay, look at the K. Okay, and you have four bouncing there, and there's number 2. Now there's a question that I want to ask you, and we want to discuss. How do you think letters and numbers can work together? What are your personal thoughts and understanding of how letters and numbers can work together? No cheating. We're looking into the book, we're trying to explain anything. I want to know your thoughts, your own thoughts. Prior to learning anything, what were your thoughts in association with letters and numbers? What are your thoughts, Fatima?
I think maybe letters can be used to represent a number.
You think letters can be used to represent numbers? That's a very, very good thought. Okay? We're going to look more in detail at whether or not that's possible, but thank you for sharing that. Excellent. Okay, anybody else want to say anything else? How many letters of the alphabet do we have? What about numbers? How many numbers do we have? Infinite, very good. Numbers don't end, letters do. Okay? So that's just something we think about as well. Anything else that you think can relate letters and numbers? Okay? Who here thinks this is the founder of algebra? I'm sure if he's taking a sneak peek in his work, he's really like, yes, I knew all along. Okay, well done for that. Okay, and we're going to look at that briefly as well. So we're going to look at what relationship letters and numbers actually have. Now, before we do that, okay, at the bottom of your worksheet, we're going to go right to the bottom. There's 2 sets of exercises that are identical. So for the first one here, it says look at the first 10 questions. So you're looking at the left-hand side of your workbook. Open the book, and on the left-hand side, you will see these questions: 6 plus 5. 2 plus something, something plus 9 is equal to 16. We're going to ask volunteers to come and write down the answers. Okay, so each of these is going to be done by a different volunteer, and we're going to pull you up as you come. So the first one, 6 plus 5. We want us to, we want you to fill in the missing numbers. Who wants to do the first one, 6 plus 5? Somebody tries first. And then you go for it. Good. Good. You're going to get us going. Fill in the first one. Okay. If you can say 6 plus 5 is 11, you all agree? Yes. Okay, let's fill that in there. Okay, can we agree? Let's fill that in. Who wants to do the second one? So I'll come. Please do this as quickly as possible, so that we all participate and are actively involved in the progression. Okay. Awesome. 2 plus what gives us 7? Okay, don't worry too much if the pen is a bit wobbly. Okay, well done. Thank you very much. Who wants to do the next one? Prince. Come. Alright, 3 gentlemen have come now. We want the ladies to come. Okay? Well done. Something plus 9 is equal to 16. I wonder. Very good. Okay. Right. The next one. 12 plus what? Can I let it come? Plus what gives you 15? 11. Very good. Is she right? 12 plus 3? Yes. You all agree?
Yes, sir.
Alright, and then Tanda. That's an attempt at writing 4. No worries, no worries. Depends on chances of the good one. But 4 plus 11 is equal to 15. Do you all agree? Yes. Very, very good. Now for the second half, up to the one that says 20, I want you to finish those in your think pair share groups. Okay, don't answer any other questions except 2 plus something, 12 plus something, something plus 13. Just 1, 2, 3, 4, 5. Quickly do those in your think pair share. I'm giving you 1 minute. Think pair share. Work together, those 5, mark them together, and I'll come around to you. Coming around to you. That's the last one. Okay, 30 seconds. You guys are moving very quickly and nicely. I love it. So Chinese proverbs. Many hands make light work. When you combine efforts, things move and move quickly. Okay, last 20 seconds. Last 20 seconds. Well done, well done, well done, well done. Very good. Okay, excellent. Love it. Alright, excellent. Good, speedy, accurate work. Good, good, good. Okay, in your groups, you agree? Now the last one quickly. Right, as soon as you're done, go back to your chairs. Just those ones, just those 5 questions. Leave the other one alone. We're going to do something slightly different. Okay? Right. Now, just make sure we are all on the same page. The first one we said together, 2 plus. We have already seen in the first order of these, right? 2 plus 3. The next one was 12 plus 2 is equal to 14. 14. Excellent. The next one we said 7 plus 1 plus 13 is equal to 8. Sorry about that. Sometimes the answer just comes out. Sign of being clever cats. Okay, 3 plus something is equal to 5. 2. Very good. And then something plus 15 is equal to 20. Right. Okay, how many of you would say this is quite simple, quite easy? Okay, how many of you think it's possible for algebra to be just as easy as what we just did now? How many of you think it's possible that if it's carefully explained and you work through the processes, the steps, that at the end of the lesson, you're going to find algebra just as easy? Okay, I really, really hope that that's how everybody is feeling at the end of this. Okay, now we're going to do something slightly different and we'll go back into our think pair share groups to work out the rest of these exercises. Now, we want to talk a little bit about algebra, okay? But we're not going to introduce it yet, but we want to try something, and then as we go, we're going to keep discovering more and more information until we're able to meet our learning markers. Now, let's imagine for a second that instead of saying 6 plus 5 is equal to 11, we decide to give the value of that box the letter A, okay? Now you've worked this out. You know that 6 plus 5 is equal to what? 11. So what was the value of A? 11. Do you all agree? Yes. So if I put a letter A in the box, the value of A must be 11 to make this statement true. Do you all agree with that? Yes. Do you all agree with that? Yes. Okay, let's look at another one. Okay? And then you're going to carry on with this exercise and you'll think A share groups. Okay? We've already done this one, we've worked it out. Let's, for argument's sake, decide to call this B. 2 plus B is equal to 7. What is the value of B? How many? 5. B must be equal to 5 to make that statement true. Do you all agree? Yes. Alright, so on the second group, in your think pair share group, I'm giving you 2 minutes this time. You're going to decide on the letter that you want to put inside each of these boxes. Okay? Once you decide that letter, underneath the statement, you're going to write the value of that letter. Okay? But remember, we've already worked these out. We filled in the missing numbers. Now we are replacing the missing space with a letter. And we are now giving that letter a value. Are we together? Tana, your question.
Do all the letters have to be different?
If possible, let's try and be different with all of the letters. Okay, let's try and use a letter that we didn't use. Remember, we've got 26 letters of the alphabet. Why do you just want to put B, D, B, D? Do you want to do that? Oh, it's boring. So let's give it variety. Try not to use the same letters again. If you do, look, it's not a crime. But what's important is that each of these boxes is replaced with a letter, and underneath the statement, you are going to write the value of the letter. Yes.
Is it okay if we, for example, if the answer is 20, and for the other person is saying what does other people say?
No. Each question must be treated independently. That's why we're looking specifically at just this question. 6 plus 5 is equal to 8. Excellent question. Okay? But we are saying A is equal to 11 because we chose to make A the letter that we are choosing. So we are saying these two numbers are equal to some unknown letter A. And we are saying the value of A must be 11 because 6 plus 5 is 11. You all see that? Okay, so what we're doing is we're replacing the box of the square with a letter. You'll understand very soon why we're doing this. Okay, you happy? So back in your think pair share groups this time, 2 minutes. Let's go bring it and then you're going to check your answers. 2 minutes. 2 minutes. 2 minutes. Okay, 2 minutes. Discuss with your friend. Let's see. Whatever letter you decide to give it, then write the value of that particular letter like I have done. Follow the same format that I've done. Decide to give it the letter S, then write the value of S. You must both be filling in at the same time, not just one person. Everybody must participate. That's why when you're a partner, check on what you're doing so that you are also doing the work. Okay? You're working together. You're not just writing down answers. You decide to both say that's A, so what is the value? Okay. Remember you've done this before. So you go back to what you worked out and you say, what must the value of A be? So A must be? Exactly. So you say A is equal to this. Okay, very good. Right, good. S is equal to 7. Very good. Well done. That's very nice. Okay, you guys are okay, good. Good collaboration here, guys. Excellent. Let's have a look over here. Okay. That's 5. Okay, good. You've got less than a minute left. I love the way you guys are working. So diligently and conscientiously. Okay. You must all, whatever your answers are, they must be the same because you're working together. You are thinking, you are pairing, you are sharing. Discuss. If you're not sure, you can ask me, but I'm pretty sure you can do these on your own. Just call me if you're not sure about something. Discuss. Okay, straight up the pace here, guys. You need to finish. The time is almost up. Yeah, decide on the letters and we can give them values. So underneath you write, what is the value of E? Yeah, you see what we're doing. We're explaining, talking, collaborating, relaying information together. Okay? Are you happy? We've checked all the answers. You happy? Okay, guys, once you're done, you can go back to your seats. Okay? Double check your answers and be sure you're happy. Whatever your letters are, and when we mark this very, very quickly, it doesn't matter what letter value you chose. What's important is that the value is the same as what we put on the board this time. Okay, do you agree? Okay? Very good. Excellent. Just sit down once you're done. Okay, go to the last one. Make sure. Alright, Prince and Princess, you guys can be finishing. Time is up. Pick up the pace. Okay. Excellent. Alright. Happy? I'm very pleased. Good. Well done. Okay. Well done, last one. Well done. Give yourself a little clap. That was actually easy. Okay. So again, because we don't want to waste time, alright? I'm just going to go through these very, very quickly. Okay? Whatever your unknown letters are, I did these, okay, just following the letters of the alphabet, okay. I made that E, I made that F, I made that G, I made that H, and I made that R. So what I'm going to do now is I'm just going to call the letter, and you're just going to tell me the value. Okay, take your pencils out, you can set them out quickly. Alright, what is the value of C here? 7. What's the value of D? Okay, let's try that again. No, some of you were not listening. What is the value of C? 7. What is the value of D here? 3. Whatever the letter you chose, the value here must be 3. The value of the letter you put here must be what? 3. Okay. What is the value of the letter that you put here? 4. 4 plus 11 gives us 50. What is the value of the letter here for you? 3. Okay, so E here is 3. I said here C is 7. I said here D is 3. Here I said E is 4. Sorry? Sorry, that's right. Okay, F is, that's supposed to be F. Repeated the letter E. Okay? So that not going to change anything, it doesn't matter. F here is 14. G is 7. Very good. 3 plus H, what is the value of H? 2. H is 2, very good. And I is 5. Okay. Are we all happy with this? And the process by which we went about. We chose a letter, replaced the box, which is the missing space with the letter, and after doing that, we then found a value of a letter that represents what a number would have done. Can you see what we just did there? We replaced the letter, a number with the letter, and gave that letter the same value as the number that we chose. You would agree with me?
Yes, sir.
Any questions on that so far? Alright, let's proceed and see where this is taking us. Okay, I'm just going to clear the board, and then we're going to continue and see where this is going. Alright, we've done the same questions, we've finished this exercise we've just done, well done, okay? Now we're going to talk a little bit about this chap. I know most of you are wondering, who is this guy? Why is he so special, okay? I can't pronounce his name, it's in Arabic, but I know his first name was Muhammad ibn Musa al-Khwarizmi. Okay, he's known as the father of algebra. Okay, he was a Persian mathematician. Okay, he lived a very, very long time ago. And he wrote a book which he translated into English. Is the compendious book on calculation by completion and balancing. He's the guy who came up with algebra, with equations, and all the rest of it. Okay? So if you ever get angry when you're doing algebra, this is the guy to name. Okay, but thanks to him, the world is a much, much better place. In fact, some people actually say algorithms were named after him, after his name, algorithms. Algorithms. Okay, he's the one who came up with this. And that's the reason why we can enjoy computers today. Okay, so it's quite an important character in history. He is the father of algebra. That's why I put a little excerpt in your workbooks and want to just explain to you who the guy was. Okay, you saw him at the beginning when we had the letters. Now you know who he is. Okay. So turn to the next page on your worksheets. We're going to go to worksheet 2. Alright. So what is algebra? That's the big question. Okay? I want to carry on and answer the question as well, because based on what we've done so far, but before I put the definition, what do you think algebra actually is? We've just done an exercise, and we're asking ourselves, okay, what did you just do and why did you do it? Mohammed?
It's a way that letters represent numbers.
My friend, well done. Well done. Give him a hand. Absolutely professional. Okay, Mohammed has literally said it exactly. Simply put, algebra is the use of letters to represent numbers. Say it with me, algebra is the use of letters to represent numbers. Okay, there's a little space for you to fill that in on worksheet 2. Algebra is the use of to represent. Again, I'm just going to give you definitions. Some of them you need to pay attention. You fill them in yourself. Okay? Active participation, very important. Otherwise, information is in one ear and out the other. Okay, so simply put, algebra is the use of letters to represent numbers. So we treat letters the same way we treat we treat letters the same way we treat numbers. And that is the trick. Once we do that, everything else starts to make sense. Okay? And then very quickly here we say letters are used to replace numbers. The letters that are used to replace numbers are called variables. Now that term variables comes from the fact that the letters can vary. Remember when we did our exercise, we had A, some of us chose B, some chose C, some chose S. others chose G. Doesn't matter. You all chose various letters. That's why we call the letters variables. Okay, why do we call them variables? Because they can have varying values. Okay, A can be 6, A can be 7, C can be 9. It doesn't matter. The letters can vary, the values can vary. Are we together? So we call the letters variables because they can vary. Right, here are some examples of collecting variables. That is, terms that are the same. So when we collect variables like the letter A, any apple, if I have 2 any apples, they would be like terms. They are the same. If I have 2 bouncing beans, they would be the same because they are both of them. So if I have 2, I've got 2 beans. If I've got 3 clever cats, I've got 3 C's. We're going to look at a couple of examples. So over here, if I've got 2 any apples, A plus A, how many A's is that? So I write what? 2A. Why? Because I've got 2 A's. What about if I've got 2B plus 3B? 5B. Okay, 2 bouncing beans plus 3 bouncing beans is 5 bouncing beans. What about 4C minus C? 3C. Very good. So collecting like terms means adding or subtracting the terms. Okay guys, we need to speak up a little bit because of the thunder and the rain that started with the natural elements. Okay? So let's continue. 2A plus A, what is this? 3A, well done. Okay? 2B, 3B plus 2B minus B. Mariana. Okay, very good. And the last one we found out 6C minus 3C. 3C. Okay. Are we all happy with the way we can collect terms? By adding or subtracting terms that are like terms or that are the same. So on your worksheet there, it says collecting like terms. So an algebraic statement, the expression, the first one there, we said an algebraic expression, we wrote it over here. Any statement with letters and numbers is called an algebraic expression. Okay? So on your worksheet there, there's a part where you're supposed to fill in what is an algebraic expression. Okay? So make use of that definition quickly. Okay, it's very important that we know what an algebraic expression is. Okay? Any statement with letters and numbers is called an algebraic expression. So we spoke about this in the beginning of our learning outcomes, but you weren't sure what that was. So now we're saying an algebraic expression is one where there are letters and numbers. So things like 2A, 5B, 3 plus A, all those are algebraic expressions because they involve letters and numbers. Are we happy with that? Yes. Very, very good. And then the next expression here is collecting like terms. What do you think collecting like terms means? We've just finished doing it. How would you define collecting like terms? Yes. Okay, adding the same letters or adding or subtracting the same letters. Do you agree? Okay, so collecting like terms can be defined as adding or subtracting the same variables. Okay, adding or subtracting the same variables. Do you agree? Collecting like terms is adding or subtracting the same variables. So the key two words there are adding or subtracting the same variables. Adding or subtracting the same variables. Okay, adding or subtracting the same variables. Okay. I'm going to put you back in your think pair shape one more time to do 6 quick questions. Okay, and then the operations only algebra is what we'll look at next after this. Okay. Operations involving algebra is what will come after this. Okay, so what This is adding or subtracting the same variables. Okay? Now, on your worksheets, okay, there's connect the like terms below. That's what I want you to do. Think patiently. You have a minute. Connect the like terms below. Just give you 1.5 minutes. Okay. Connect those like terms. Very good. Wow, you guys are fast. Yes. Looking at a nice face. Very good. Okay, guys, let us give it 45 seconds. This is so quick. Well done. Well done, well done, well done. Well done. Well done. Right. Okay, remember to include which variable it is. Now there's something that I'm going to explain just now that I've already seen. Once you're done, you can go back to your seats and we'll look at those right now. Switch. Okay. Alright, hold on. Now, the questions that are there, I'm just going to write them on the board here. You all got this 4n plus 3n, and we all said that the answer to that one is, how do you look? 7n, very well done, it's very easy. We had then 7y minus 5y, and we said the answer there is, you guys have said something, Angela. Very good, well done. And then we had 4p plus 3p minus 5p plus 2p. Now, I want you to pay attention to what I'm going to say here. Okay? All those terms added together, collected, what happens in the end? You add 4 plus 3, you get 7. You take away 5, you get 2p. Okay? So that's 7 minus 5 plus 2p, which gives us 4. 4 what? 4p. 4p. You all agree? Yes. Very good. And then we had 19 minus 19x minus 2x. And what did you get for that one? 17x. Well done. And then we had 4y minus y minus 3y. This is the one that I want to pay careful attention to. The team, what do you think the answer is here? 0y. Now, do we talk about 0y? What is nothing? Does nothing have a unit? Nothing is nothing, right? So, you can't say I have 0 oranges. I have 0, I just don't have any. If there's nothing there, there are no oranges. So you can't have 0 oranges. You can only have 1 orange and above. Right? So the answer works out that you've got 4y minus y, which is 3y minus 3y. The answer is just 0. Okay, you don't talk about 0y. The same way you don't talk about having 0 cooler. Okay? There is no 0. You understand what I'm saying? Yes, your bank account can say you've got 0. We're talking about what we can do and have in our hands. Nothing is nothing. Okay, so we don't talk about 0y, we just talk about 0. Okay, I want you to be familiar with it. The same way when you say 5 minus 5, you don't give that a unit. You just say 0. So x minus x is also 0. Remember, we treat letters like numbers. and the rules are the same. When we subtract the same numbers, we get 0. When we subtract the same letter, we get 0. We don't have 0 out. Does that make sense, everybody?
Yes.
Alright, and the last one there, 8x minus 4x plus 5x minus 2x, the answer there is 7x. Well done, everybody. Okay, you can solve the mark there out of 6. Okay, very good. Now, operations involving algebra, we're almost done. Operations involving algebra. We said that at primary school we focus on 3 operations when introducing algebra. Okay? We look specifically at addition and subtraction of variables, which is what we've just done. Now we're going to look at multiplication of numbers and variables. Okay? We've already been doing it, you may not realize it. So you've got a plus a plus a plus a. It's the same as saying 5 multiplied by the letter a. So we say it's 5a. So the expression 5a actually means 5 times a. That's what we mean. Okay? And this is what we mean. So 5a means 5 lots of a. But remember, I've said this before, that multiplication and addition are related. You know, we talk about tables. We count in 3s, 3, 6, 9. And then we have the multiplication table. 3 times 1, 3 times 2, 3 times 3. And the answers are exactly the same as if you were just adding 3, adding 3, adding 3 each time. Make sense? So when you add the same letter, it's the same as if you're multiplying the number and the letter. So however many a's you've got, you multiply by the number of a's that are in. Okay, so for example, if I had a plus a, that would be the same as saying 2 times a, which is 2. That's what we mean. Because there's 2 of them. And you multiply a by the number of times a appears. Yes.
So does that mean if there's a 5a and then there's no symbol nearby, like addition, that means you multiply?
No, it doesn't. It actually means every time you have 5a, it just always be multiplied. It means 5 times that. Okay, and we're going to look at an example involving numbers so that this becomes more true. And I've explained it in great detail here. So 2 plus 2 plus 2 plus 2 plus 2 is equal to 10. You all agree? But how many lots of 2 do we have? 5. So 5 times 2 is what?
10.
Same rule applies to numbers. Same rule applies to letters. Okay? So simplify the following. And we're going to simplify these 3. Alright? First one, tell me. A plus A plus A plus A plus A is? 5a. So what have you done? You've basically multiplied a by the number of times a has appeared. Then you've got b plus b plus b, which is 3b, which means you've multiplied the number of b's by the number of times they appear, 3b. Then here you've got c plus c plus c plus c plus c plus c plus c. How many c's do we have? 7. So we write what when it becomes? 7 c's. Okay. And that's how we do it. Okay, you do fill yours in from the worksheets, and then you can go to the second last worksheet. We're almost done. Alright. All of this is leading up to the last part of our learning outcomes, which is equations. Okay, which is equations. We are going to look at those in a minute. So everybody managed this whole term? Worksheet 3, the introduction to equations. Remember to speak up because we have any range outside. Okay. Now, I've deliberately put in there a picture involving scales. Remember we spoke about the Rwanda and father of algebra. We came up with a way of balancing and connecting. Now, these scales here means whatever's on this side is equal to whatever's on the other side. Okay? So when we talk about what an equation is, it's important that we realize that in the word equation, we have EQUA, which is where we get the word equal from. So what do you think the equation is? Looking at that picture over there, how do you think we can define an equation? Does everybody want to try to define an equation according to what you think an equation is, based on this information? Yes.
A number sequence.
Number statement, okay? What statement does involving what? It's a very good attempt. Yes. Okay, so number statements involving operations, multiplication, etc. All of that is very correct and very true. Okay, but we can even simplify that a little bit further. Okay, and we can even just call it an algebraic expression with an equal sign. As long as it's an algebraic expression, 3 plus b is equal to 5, that's an equation. Okay, so you've been dealing with equations the whole day without even realizing. But we didn't want you to start with equations, we wanted you to build up the knowledge leading up to the equation. So x plus 4 is equal to 6 is an equation. And we need to solve it by finding out the value of x. So this number x must satisfy the equation, meaning what is x, so that when we add 4 to it, we get 6. What is x? X is 2. And that's the solution to the equation. Okay, so all of the things that you've been looking at all along, those are the basics of the equations. Because there's been an equal sign, and there's been an algebraic expression. All together? Yes? Now you're going to have fun with doing these ones. Okay, now, how do we solve equations? There's different types of equations. Okay? Look at this one. These are called one-step equations. In other words, there's only one step involved in solving it. Here, you're simply looking at which number plus 3 is equal to 6. You can actually do this in your head. Okay? Then there's two-step equations where there's an unknown. Now we know that 2x means 2 times x. We know that a certain number, 2 times x, was added to 4, and then the product is the same as whatever the value of x is plus 6. Now these multi-step equations, we don't really do these at primary school. Okay? But you are able to do these. By the time you get to like Form 1, you start doing a lot of multi-step equations. We deal mainly with one-step and two-step equations. You can also do systematic equations because these are simple. These are the same as two-step equations. Okay? These ones involve a slightly more complex process, and maybe in our next lesson we can try and see if you guys can actually figure out what's going on. Okay, so these are multi-step equations which you will do higher up. But we focus mainly on one step, two step, and sometimes systems of equations. Okay. And I just wrote here that there are different ways to solve simple equations. We're going to look at those just now. Look at the notes that I've given you in your book. Right, now in this expression which I've explained just now, x plus 3 is equal to 6, we must ask what number plus 3 gives us 6? The answer is 3. Okay, we've done these, we know how to do them, therefore the value of x is 3. We've done this. From the beginning we've been reinforcing the same thing all along. Okay, so we say x is equal to 3 is the solution of the equation. So when we say solve an equation and you give us the value of the variable, you have given us the solution. Okay, and we can check. If I say 3 plus 3 doesn't give me 6. So the initial statement x plus 3 is equal to 6. I then do what's known as a check. And I say, well, 3 plus 3 is equal to 6. Therefore, x is equal to 3. That satisfies the equation. You all see that? Yes. And we always do a check to see whether or not the solution that we come up with actually satisfies the equation. Alright, happy? Alright, let's speed it up because we're almost done. So 2x plus 3 is equal to 6 is slightly more complex. Okay, I've written all this in your notes, but I want you to also demonstrate it to it. So over here, you've got 2x plus 3 is equal to 6. Now, because we now understand that 2x means 2 times x, and then we added 3 and we got 6. So we had some unknown number x, which we don't know. It was multiplied by 2, and then we added 3, and our final answer was 6. Okay, this is a two-step process, and these are the more complex equations, which we will do a couple of these questions as well. So the way we solve this is by working backwards. Somebody say backwards. So initially, the first step was to multiply the unknown by 2, then I added 3. My answer was 6. Now I start at 6, and I go backwards. I added 3. What is the opposite of adding 3? So what is the opposite of adding 3? The opposite of adding 3 is subtracting 3. So I say 6 minus 3 gives me what? 3, right? Now what is the opposite of multiplying by 2? Dividing by 2. So I divide this by 2 and I get what? 1.5 or 1.5. Now x is equal to 1.5. Can I check? If I multiply 2 times 1.5, this is check now. If I multiply 2 times 1.5, then I add 3, what happens? 2 times 1.5 gives me 3 plus 3. My answer is 6. Can you see that x is equal to 1.5 is the actual answer? But I solved that by doing the opposite. So I say, what happened first? X, 2 and x will multiply. 2 times x. Then we added 3. And we got 6. So I start with the answer, which is 6. So I take 6 and I work backwards. What was the last thing I did? I added 3. Now what do I do? I take away 3. And I get 3. Then what did I do first? I multiplied the unknown letter by 2. Opposite of that is to divide by 2. And that takes me to the original value of x, which is 1.5. Then I substitute 1.5 into this equation. And I say, if I multiply 2x, which is 2 times x, 2 times 1.5, it gives me 3. Okay? 3 plus 3 is 6. Those are the more complicated equations. That's what you're going to be doing for one. Guess what? You can do it already. Alright, that's why we're doing simple equations. When you get to Form 1, you'll be revising what you're supposed to learn in primary school. Okay? But don't just take my word for it. We're going to look at a couple of examples. Okay? And get familiar with this process. Okay? So all this is in your notes. To solve this, we must work backwards. I've written all this for you so that you've got a written record in your workbook. You can come back to this anytime if you get confused. So we start with this, then we subtract 3, we get 3, then we divide this number by 2, as this is the opposite of multiplying by 2. The answer we get is 1.5 or 1.5. This is the solution of the equation. You can check by saying 1.5 times 2 plus 3, and we get 3 plus 3, which is 6. I've explained that in your notes. Okay? And we're going to look at simple equations. And doing our think, pair, share activity now. Open your books to the next page. Okay? Where we've got multi-step equations. Are you all there? This is multi-step equations. Okay? So it says that 2x plus 3, that's the one that I've done. I've already explained that. Now solve the following equation. The first equation you've got there is 7 plus k is equal to 16. We already know how to solve these ones. How do you solve that equation? You look for a number that 7 plus k is equal to 16. How do we solve it? 7 plus k is equal to 16. How do we solve it?
You can subtract 16. You can subtract
7 from? And we know that the value of k must be 9. That's it. So in your think, pair, share groups again very quickly, I want you to do numbers 1 to 5. We're getting ready. So remember when you're writing your answer, you say the value of the unknown. A is equal to 9. Very good. Very good. Well done. Very, very good. Oh, okay, good. Very good. Very good. Almost done. So then just the last exercise, 1 to 4, and I'll elaborate and do this now. Well done, guys. That was very good. Okay? So can we all agree? Where you are standing with your partners, listen to me. Can we all agree that the value of K is 9? Very good. What is the value of Y? That's what I'm seeing as I'm walking around. Very good. What is the value of B? Excellent, guys. Well done. What is the value of C? Fantastic. And the last one, the value of V? bigger than 53. 11 bigger than 53 to be exact. So the answer for that one is 64. So 64. What you did here is you subtracted 54, but here you subtracted the opposite of that, add. Okay, if you want to correct yourself, very good friends. You add 11, and that's how you correct yourself. Okay. Now we're going to look at our collaboration groups. I want you from where you are now to quickly go to your collaboration groups. The last two activities are in our collaboration groups, and they'll both take about 3 minutes. So let's go to your collaboration groups. Group 1, Group 2, Group 3, Group 4, Group 5. The last two collab discussions. So let's move to your collaboration groups. We're going to do a main dissemination to collaboration shortness. Alright. So we've done the linkage activity. Now we're going to do the collaboration. Now for the collaboration, the first part here is we're going to solve the multi-step equation. Okay? And the first multi-step equation that we've got in front of us there, can you all see it? Is 3x plus 5 is equal to 11. Okay? So we've got 3x plus 5 is equal to 11. Now remember what I told you. I said we work backwards. We start with 11. What was the last thing you did? You added 5, right? So what is the opposite of adding 5? You need to? So you say 11 minus 5, and that gives you what? 6. The last thing you did here is you multiplied x by 3. So what is the opposite of multiplying by 3? It is dividing by 3. So you take the 6, divide it by 3, you get 2. So your answer is x is equal to 2. Forgive me for writing here. The questions are on your worksheet. Okay? So 3x plus 5 is 11, x minus 5 is 6. 6 divided by 3 is 2, so the answer is x is 2. And you can quickly, you don't have to write check, but you can check. If you multiply 3 times 2 and we add 5, does it give us 11? 3 times 2 is 6, plus 5, does it give me 11? Yes. Okay, so let's do those in a big collaboration. These are more complex. I want you to solve the last 3 questions in that one. Okay, this is the second last activity and we're done. So your collaboration, I'm giving you 3 minutes. I've done the first one for you. It's on the board. In your collaboration groups now, do the last 3 and solve those equations. Discuss in your collaboration groups. Discuss. So we work backwards. 3x plus 5, so what happened? Here, 6p minus 7 gave you 5. What's the opposite of taking away 5? What is the opposite of taking away 5? So you're taking away 7. You're going to add. It's 12. And then last time it's 12. So you start with 5 and then you add 7. So you start with 5. This one, I've already done the first one. Okay, what's the first one? Guys, in your collaboration, the 4 of you working together. Let's go. Together, discuss. Don't try and do it on your own. You will never ever figure this out on your own. To discuss. 1, 2, 3, 4. Face each other and talk. Face each other and talk. Face each other and talk. Converse and discuss. Okay? So 3 multiplied by x plus 5 is 11. Okay, you start with 11. The last thing you did was you added 5. So you start with 11, you take away 5. What was the first thing you did? You multiply the unknown by 3. What is the opposite of multiplying the unknown by 3? It's dividing by 6. So whatever your answer is 6, divide that by 3 is multitude. That's your work. And you follow the same working for each one. You've only got 3 questions to do this one. Okay, the last ones are much easier than this. These are the only complex questions that we have. Okay, discuss and collaborate. Okay? Let's solve this. Discuss together. Discuss and come up with a solution together. Saying why. So what is the opposite of taking away 7? What is the opposite of taking away 7? We've got 5. We start with the number 5, right? We've got 5. Last time we took away 7. So what is 5 plus 7? 12. Good. Everybody starts with 5 plus 7, which gives you 12. Then instead of multiplying by 6, we are dividing by 6. So that's your answer. Easy, easy, easy. And this requires you to follow the steps of the process. Okay? Oh wow, you guys are amazing. Wow. Sure. You guys are good. This group here, hats off to you guys, right? You got it. Well done. Well done. Guys, be encouraged. Also here, you guys are also doing all this. The right muscles are coming up there. Very good. Yes. We're getting there. Discuss, guys. You're in a group. You're not working as a collaboration. It's nothing crazy. Collaboration. So 1, 2, 3, 4 minds on one person. Discuss. Okay, come on. And you're discussing all 4 of us, not just 4. Because so you can make use of love, make use of love. Discuss the discuss. Okay, if you get it wrong, all of you get it wrong. Yes, help each other. If one of you gets it wrong, you all get it wrong. It's not individual work on the group. It's collaboration and discussion. So, Ariana, you guys come up with one or two. You guys are going to get nothing. None of you do this together. Work together. Overcome the challenges. Share information. Discuss with each other. Right, 1 minute. 1 minute. You guys are okay. You guys have done them all correctly. You guys have done those all correctly. Discuss with the group. Make use of it. Okay? So what you get? Discuss with Mariana answers. 30 seconds. 30 seconds. Alright, let's wrap up. We are almost finished. Alright. Because of time, I'm going to end on this particular activity. Okay? Whatever I haven't completed today, I will teach tomorrow. Okay, is everybody done? I want us to wrap up now. Alright, let's go back to our groups. Let's go back to our groups. Alright, let's go back to our groups. Sorry, to our bases. Let's go back to our bases. Okay, let's go, guys. Time is up. That looks good. Yes, great job. Alright. Those that still don't get it, don't worry. So that's good. That is correct. So what happens when you collaborate? But now, you getting it all right, but you're not sharing the information with your friends. This is what we mean by collaboration. Collaboration means what I'm coming up with, what's going on here, I'm discussing with a friend. I know it's not something that comes naturally to you, you've taught your whole life, things on your own. We're trying to teach you to be able to share. We're trying to teach you to collaborate and share information. Okay. You don't have to be friends, but it means you work together. These guys have all worked together. They all come up with ideas. They're here to deliberately. Okay. You're all very good at maths. You need to work together. You're getting all the right answers. Who knows? Shami started to get the right answers. Each individual work. It doesn't help from us. You know what I'm saying? So think about that for each. Okay. Right, guys, really quickly, everyone. Pay attention. We're wrapping up now. This is the last thing we're going to do. Right, now we want to recap. Everyone got the basics. I'll take the workbooks and go from there. I've already walked around and seen the answers, and most of you have done wow. Okay? Just very quickly, let's go back to the beginning, and we're going to talk very briefly and say, what are the 3 learning outcomes if you remember what we discussed? We're just recapping and checking if we have achieved our learning outcomes. We may not be perfect at solving equations, but we have an idea. That's what we want to be. Remember, practice. Evaluate the practice makes perfect. And the more we evaluate our practice, look at what we're doing, and look at carefully, we are able to improve. I'm not expecting everybody to get everything at the same time, but we want to expose you as much as possible and help you learn new things as we go. Okay, so the learning outcome number 1, what was the first learning outcome? Go back to the front page of the worksheet. What was the first learning outcome?
Learners will be able to define the term algebra and how it is used in mathematics.
Okay, we've been able to identify algebra. You can tell us, what did you say algebra is? been able to define algebra? Fatima?
Algebra is the use of letters to replace numbers.
Okay, the use of letters to represent numbers. Have we managed to learn how to do that, Akunda?
Yes, sir.
Have we managed?
Yes, sir.
How many of you feel, hands up if you feel you've managed to achieve that today? Step number 2, learn us to be able to carry out basic mathematical operations involving algebraic expressions. Have you been able to do basic operations involving algebraic expressions, yes or no? Very, very good. And the last one, sorry, learn us to be able to create and solve simple equations. Okay, we've been creating lots and lots and lots of simple equations. Okay, and we've been using letters and numbers together to be able to combine and create. There's one exercise which I'm going to give us as homework. I'll explain that, and we will do that for homework just to practice creating and solving very simple equations. Okay, we will end here for now.